Merci bien. Bonjour tout le monde. J'arrive en direct de Montréal. Alors, on peut se parler avec mon français un peu compagnard. Mais avant que je change en anglais, parce que la plupart des termes, je n'ai pas vraiment le vocabulaire, j'aimerais me souvenir à M. Juan Enriquez, qu'ici, c'est la ville de Jules Verne et de Gustave Eiffel et de l'entrepreneuriat. Alors, peut-être il n'y a pas tellement de compagnies dans les derniers 15 ans, mais il devrait regarder le Tour Eiffel, juste pour se souvenir d'où vient la génie française. En tout cas, my name's Alistair. I'm going to talk to you about something that has very little to do with what I usually do, which is business model innovation. We've had a lot of speakers here talk about how we shouldn't try and predict the future. And I think that's true for the very long future. I think it's safe to predict the next 10 years, or at least to talk about what we should do if the next 10 years happen in a certain way. And I think the three big forces that are shaping the next 10 years of technology are big data, smart agents, meaning AI, and interruptive interfaces, that is, interfaces that tell you what you need to know at the right time. And I'm going to spend the next 40 minutes or so talking about that. This is me when I was very young. And when I was a little kid, I had a computer that looked like this. And when I turned this computer on, I told it what to do. I could just as easily start writing a line of code as I could type in play Loadrunner or Karateka and start playing a game. And that changed with the advent of the PC. I mean, this is a very early chatbot agent. But these agents quickly evolved. So today, when I use my mobile device, I wake up to a list of small red circles that tell me what the machine expects me to spend my day doing. I lead my life from a tyranny of small red circles. And I think this is the start of a technological path that will shape humans for the next 10 years. Because big data is widely defined as more data than we can go through by ourselves, which means you need a computer or an algorithm to go through it for you. And when that algorithm has found something interesting, it needs a way of interrupting you, of telling you, I have important information for you right now. I have something to give you that you will find useful. And that trifecta changes what it means to be human. So to put things in context, you've had a ton of amazing presentations. Every consultant likes two-dimensional graphs, so I thought I would make one with my fellow presenters on it. We've looked at the future, we've looked at the past, and we've looked at the present. We've looked at biology, physical technology, and virtual technology. And so I'm going to try and paint a picture about the near future on the physical, but mostly on the virtual and digital technology side. The first of the three things is big data. You've all heard the term big data. What does it mean? Well, what it actually means is something that was defined by an analyst 15 years ago. It's three things. It's the volume of data, so how much data you have. It's the velocity of data, la vitesse, how fast you can analyze it. And the variety of data, how different is the kinds of data you're analyzing. Many people in the technology industry will tell you this is nothing new. And I agree with them. We've been able to analyze these three things for a long time, but it's always cost us a lot of money. So normally, you've been able to pick any two of those three reasonably affordably, but to do all three is a problem. Pensez par exemple à la bibliothèque. Beaucoup de livres, beaucoup de variétés, mais la vélocité n'est pas là. It's very hard to extract books quickly and put them back in without breaking the library. Or consider a coin sorter. You can pour a very large number of coins in. It will sort them very quickly, but that only works when you have a few kinds of coins. Because for centuries, and certainly for decades, big times fast times varied has equaled a constant. And what big data is that the constant is getting really cheap. So cheap that when you Google something, Google doesn't even know how to bill you. The best they can do is show you ads. When things get really cheap, new ideas happen. This is an important lesson from history. There's a guy named Newcomen who built something called an atmospheric pump. This was a coal engine that pumped water out of the ocean. It was beaten by Watt's steam engine a few years later. So Newcomen's engine was not very efficient. James Watt built a steam engine that was 4 times as efficient. And the British were amazed because the entire British Empire was running on coal. So they hired someone named William Stanley Jevons to measure how much coal there was and how long the British Empire would be able to survive on the energy that lived in the ground. Now, what's amazing is that Jevons did not conclude that things were getting better. Jevons looked at this and said, hey, wait a minute. Maybe he didn't use these words. Why is it that if we have more efficient engines, we're going through coal faster and faster? This is known as Jevons paradox, because you'd think that when something becomes more efficient, we use less of it. If we get better solar cells, you'd think we need fewer of them. But what tends to happen with utility technologies is that the more we produce, the more we use. Because efficiency means we find lower costs, and lower costs means we find new uses. And new uses means we find more demand, which in turn means we consume more. So instead of a reduction, we see an increase. And big data is about this abundance. It's about the fact that we can analyze everything virtually for free. Now, I talk to a lot of companies doing enterprise big data, but I care much more about consumer big data. Every 10 years or so, something comes along from military or from the enterprise and finds its way into the general public. So, for example, client-server computing gave us the home PC. The internet from DARPA gave us the public internet we know today. The pager on your hip, or Gordon Gekko in Wall Street on a beach with a big brick of a cell phone, gave us teens texting one another in a shopping center today. So what happens when big data, you see what I did there, big data? What happens when big data becomes a consumer technology? What happens when this really goes mainstream? So here's my first big prediction. That 10 years from now, we will have a life feed. We will have a stream of information that is the dominant means with which we administer our lives. We will manage every part of our life using this feed. It's a very different way of thinking. One way to look at it is companies have ERP. You're going to have lifetime requirement planning. We already have a ton of data for this. We have tracking data from your feet, and spending habits, and calendars, and health data. And it's not any one of these things, it's all of these things put together with a puzzle. But it's actually even more than just these things. Most of this data already exists. You have information on your speeding tickets, on your income tax, on vaccination and medical history, on your education, on your cell tower movement. All of these things exist, they just may not be yours. In fact, if you look at cell tower data, I can show you where you've been based on that data, proximity to cell towers. I can look at your commute routes and figure out where you work and where you spend your time. I can look at purchases that you've made based on a certain location. This data all exists. It's just not yours yet. I can look at bank withdrawals, airplane travel, and so on. And so the first pillar of this future I see is that we will have a world where we have access to all of this information. There's a second pillar. The second pillar is smart agents. And these smart agents, their job is to mine and refine that data, because smart agents means something very specific. All of these technologies you hear, chatbots, AI, machine learning, what's interesting is this is code that upgrades itself. This is the difference between the software you know in the past and the software we're going to know in the future. Is that every night when you go to sleep, that software writes a better version of itself, probably tailored to you. This is good because humans are very bad at managing our past. As the author of Getting Things Done said, your mind is for having ideas, not for holding them. Most of what we store is never looked at again. How many people here have looked at more than 10% of their Facebook photographs a second time? We store a lot of data, we almost never look at it. We manufacture our memories. In a study done after 9/11 in the US, 73% of Americans were certain, could tell you where they were, seeing the footage of the first plane hitting the World Trade Center, North Tower on 9/11. Footage aired the next day. Nobody ever showed TV footage of the first plane hitting until 9/12. But 73% of Americans are certain where they were when they saw it. It's not just that we're bad at remembering things, we actually reinvent our memories. If I tell you that you see a video of a car, and I ask you, how fast did the two cars smash into one another, you'll give me a very different answer from if I say, how fast did the cars connect with one another? So our memories are very bad, but we have help on the way, because companies like Facebook are giving us prosthetic brains. Today, over 1.6 billion active Facebook users and 4 billion smartphones are waiting to help us. We're moving to a world where our smart device becomes a prosthetic brain chewing on all of this data. Today, you hear about Siri and Cortana and Google Now and so on. But the reality is this thing is going to start whispering in our ear. I'll show you some personal examples. I was staying at an event, and in my email, it knew the name and time of the event, so it showed me the map in my email. These are all from Google Inbox. Here's a case where I say I look at Charles de Gaulle, and it knows I'm leaving on Friday, so it superimposes it on the map just for me, based on parsing my email. Here's a case where it's suggesting responses. Here's a reply from some friend of mine, and I've got 3 options that Google's machine learning algorithm has parsed the mail and suggested responses to the mail. Here's a case where I say I'm driving to San Francisco, and it says, you've got 23 minutes, and your plane leaves at 6:25. These are all today. But tomorrow's agents will go far farther than this. Tomorrow's agents are really going to change the world. This is Steve Mann. He's a researcher from MIT who for about 30 years has been wearing goggles. And at first it was a backpack. Today it's a fairly small device on his forehead. He's part of a group of people who have been recording and augmenting their world for decades. This is another guy, Thad Starner. By his own admission, he was very socially awkward. But he had a device that would do things like recognize someone's face and then tell them information. So he could say, I remember you, I know you have a daughter, and he would seem really good at parties. And he says that being able to insert that kind of information into discussions significantly changed the way people responded to him socially. Suddenly, it seems like you're interested in them. Google filed a patent last summer. This patent is method and apparatus for enabling a searchable history of real-world user experiences. It allows you to say things like, I changed the first bullet. What were the paintings I saw when the Louvre wasn't flooded? But I can say how many books did I read in May, or did I take my pills today, or show me people's faces. Google has a patent for this. Imagine having perfect recall. And then there's interruption, because if I have all this life data, and I've given it to agents to chew on and think about, what does the agent do when it has something important to share with me? Well, it should interrupt me. What interruption really means is, as Stuart Brand said, that the right information in the right place just changes your life. I'll give you a broader definition of interruption. It's augmented reality. But it's augmented reality across all your senses, because each sense is different. So for example, sight. What we think of as augmented reality today is replacing some of the photons in my field of view with something else. And that's a pretty good interface, because I have a tremendously large amount of information I can put on there. I can make it so that I only see things when I glance in a certain direction, and the resolution's pretty good. I also have touch, the Apple Watch tapping on my wrist or something else. And then, of course, I have sound. I can listen to different sounds. As we heard today, I can play you a low, uncomfortable tone when someone's lying to you, or a high-pitched tone when there's something you need to pay attention to. We probably won't use smell, and we probably won't use taste, because we need people to carry chemicals around with them. But I believe interruptive interfaces is a good way to think about the next generation of design. And as we've heard in earlier examples, the brain is incredibly plastic. When you give a brain new information, it just works and incorporates it. So for example, this is something called the North Paw belt. It was built about 10 years ago. You put it around your waist, and whichever side is north vibrates. And they put this on subjects, and they took them to a hotel, and they let them go. and they would find their way back. They'd just know where they were. They didn't get lost. All of a sudden, they were homing pigeons. And within 2 days, they didn't even notice the belt. They just knew where they were. And when they took these things off the test subjects, they felt very uncomfortable. They felt disoriented. The brain is incredibly good at taking new sources of information and making it feel like they're senses we always had. So I believe the evolution of digital design has moved from electronic printing, which is really what the first web was, just static content where we replaced ink with bits, to interactivity, where the user had some kind of say, to personalization, which is really the app world where we're tailoring content to you, to interruption, which is like, I got your back. I have information for you. I will let you know. I think chat and inbox, as I showed you my Google inbox, are the two places where we will start to see these smart agents become part of our lives. You're already seeing Facebook's new messenger features with built-in bots. I bet you don't know that Skype actually has bots in it. Next time you go look at Skype on your mobile device, try and add a user. It'll say people or bots, and you can add a bot. There are bots that will summarize pages. Don't do it now, because I'm really interesting, but you can do it afterwards. But these bots are starting to appear, and nobody really knows. Like, everyone's forgotten that the reason we have self-driving cars is because regulators said it was going to take 10 years. And then Elon Musk pushed a software update, and all of a sudden we had self-driving cars. Companies can just push bots and push AI into your inbox, and you suddenly find out that it's there. The perfect agent, by the way, would be something like Alfred from Batman. This is a person who knows everything about you. He knows when to interrupt you when it's urgent. He knows when to deal with something politely. He knows that you wear a rubber suit at night and he doesn't tell anyone. This would be the perfect agent. And I'm alluding to some of the privacy issues we'll come up to in a minute. Because if you believe my thesis, if you believe that these three things of smart agents, big data, and interruption are going to change the next 10 years, not the next 50 years, but the next 10 years, there are some pretty serious consequences we need to discuss. There are some good things about this. I mean, as we've seen earlier, our brain is incredible. It's the reason we are able to envision things and communicate, and it's got this plasticity. In fact, the limiting factor of the size of your head is how wide your mother's legs can be apart so she doesn't die in childbirth while still being able to walk. And when you're first born, your brain grows incredibly quickly. When you're an adult, your brain is only 2.5% of your body weight, but it's 20% of your food and oxygen. We are a machine made for thinking. And we've always mitigated our weaknesses. So we've always found ways to use tools. We've always found ways to build strong structures and shelter. We've always found ways to put other creatures as sources of energy. We found ways to live underwater. We found ways to disseminate information from one to many. We found ways to search the sum of human information. We found ways to amplify and subdue conversations among groups. In fact, you can think of Twitter as an RSS feed for humans. We're really good at building things just when we need them. And one of the great things about this trifecta is it allows us to manage scarce resources, because with this trifecta, I can start to make much better use of information, say medical care. With Watson being able to diagnose at the level of a senior oncologist. 4 years ago, Watson, IBM's Watson, could not diagnose better than a second-year medical student cases of cancer. Within 4 years, faster than the time it takes a student to become a senior oncologist, Watson is now able to diagnose better than a senior oncologist. So when I can take my personal data and I can buy a consultation from Watson instead of waiting in line at the doctor's, that changes healthcare. So this is really good. And it may lead to a life more optimized, because I can learn what things make me happy, which people make me annoyed, and I can start to change my life based on that feedback. These are all good things. Unfortunately, there's some bad things. We live in a world where creativity is important, and the more we tell people to follow the path that the optimal computer program says to follow, the less chances there are they make discoveries. Earlier, we heard how humans are becoming more and more like ants. One of the things about ants is they lay down the optimal path of pheromones, and then everybody follows it. And in this case, there might be food over here somewhere. The reality is that ants that follow the accepted path are not going to discover that food. When Progressive Insurance puts a thing in your car that measures how you drive and where you go and is only willing to pay for your insurance when you follow their instructions. When you can only get medical insurance for eating good food, say goodbye to the béarnaise sauce I had last night. So there's a real risk here that as we go towards optimization, we lose creativity. When predictive becomes prescriptive, when I tell you what the world looks like, and now I say this is what you should do, it changes how humans behave in very suspicious ways. I'll give you another example of how this is not a good thing. How many people here are flattered when someone remembers their birthday on Facebook? How many people don't care anymore? Yeah, thanks, Facebook. You ruin birthdays. As these machines think for us, thoughtfulness changes. What does it mean to be thoughtful? Is it that I care about you, or I just paid a lot for my software? Another consequence of this pervasive technology is surveillance. I mean, this is a big issue here in Europe, but this is me in Japan drinking hot coffee from a can. I think everybody should have hot coffee from cans. That would be great. And when I look at this picture, I ask myself, hey, it was good coffee. Why does Facebook want me to tag 2 people? And I look closely, and there's a guy over here on the right. I don't know who he is, but Facebook might, because Facebook's got facial recognition. So forget counting how many CCTV cameras you have. Every photograph is surveillance. Because whether I can tag him or not, if the authorities want to know who that is, they're going to be able to search through the entire facial repository and come up with all the people that are him, and know from my EXIF data where the picture was taken, and they'll be able to create a very good picture of where someone was. This technology leads to perfect surveillance. On a slightly more lighthearted note, you've all heard of the Turing test, right? The idea that you interrogate someone and find out and try and decide if they're a human or a machine. Let me show you a recent example. So I'm using Google Inbox, and this is a mail from my mother. I'm saying, yes, I can meet you for dinner because I'm a great son. And down here it says, she says, look forward to it. I can say, looking forward to it too, me too, or yes, see you then. These are my suggested answers. So I took a screenshot of this and sent it to my mother and said, isn't this interesting? She's pretty technologically smart. And she replies, hilarious, but deeply disturbing. And I reply, so true. And she says, now I will have to guess if this is a computer-generated response. At what point can I presume it is the real you answering? Can I presume at the moment that if it is more than a sentence, then it is likely to be a real person? I think so. And then I put, this is me. I didn't want to troll my mother too long. My mother just had a Turing test with Google's AI. Like, we talk about these things being far away. This is my mom having a Turing test. She's trying to decide if it's me or a computer. Let me give you a slightly darker example, although kind of genius. We are in the city of seduction. I am going to read you a proposal. This is from a gentleman named Casey. He's 20 years old, on Tinder. My perfect date night. I pick you up in my Ford Focus. You get in. There's candles in the car. You go, isn't that dangerous? And I go, yes, but I like danger. We go to my favorite restaurant. I have a fantastic meal. We come outside and we see my car's on fire. And you go, Casey, your car's on fire. Aren't you upset? And I go, no. I pull out a bag of marshmallows and I go, no, I knew this was going to happen. And then I kiss you in front of my burning car. Casey sounds like a fun date, right? Like, I'd probably go on a date with this guy. He sounds great. And actually, Casey's a data scientist. So the words in here have been very carefully chosen. Even where he says, yours car's on fire, or the fact that he has a Ford Focus makes him not feel too snobby. The fact that this is taken in his car, so it's consistent with the story, but the background's out of focus because depth of field usually gets better ratings. Everything has been tuned, but that's not what's interesting. What's interesting is that Casey has trained Tinder using a piece of software called Eigenfaces to learn what kinds of women's faces he likes and what kind he doesn't like, and it swipes for him automatically. If a woman is lucky enough to go through Casey's gauntlet, she runs into his chatbot, which asks a series of questions. If she's lucky enough to have made it through that gauntlet, you actually get to talk to the real Casey. Now, to be fair, Casey did this, he published it, and he actually told everyone what happened. They had great conversations about it. It was very interesting. He said most of the women were fascinated by the story. But you can see what's going to happen here is there's going to be a chatbot setting up another chatbot on a date, and then both humans will eventually find out their bots really liked each other. Here's another example of something bad that could happen. What if you're at a dinner party and you're relying on a little thing in your ear to tell you who you like and who you don't like and which people are trustworthy, and I hack it. I change the algorithm So you're really rude to all your friends, and you sign deals with all the people you shouldn't trust. I don't have to hack your brain if I can just mess with the algorithms or the data. The vulnerability surface, the attack surface for a hacker when you rely on an external prosthetic brain is huge, and we're not really talking about it. This is going to be massive. The technologies I'm describing here are going to be gigantic. We are going to analyze everything in our lives. We can already do that quite well. For example, this is a product from a company called Affectiva. What they do is they analyze visual information on the face, microexpressions, and to decide on mood. Rana El-Kaloubi, who's the founder of the company, spoke at a conference that I was running, and she demonstrated this software with a friend of mine who pulled out an iPad and held it to her face. And so now you can see, like, it's looking at her face, and up on the screen is my friend's face. And at first she goes, and it says, happy. And then she looks up and she goes, it says confused. And now she's angry and it says angry. Like in real time, she's going through all these experiences of how creepy is this, and all it's doing is just telling everybody that she's creeped out. That sounds like a nice parlor trick. Now imagine, how many of you use video conferences for business? Imagine there's a thing that when you propose the price, it tells you how many people on the other side of the phone liked your offer. How quickly would you add that feature? And how quickly would you then add a feature that doesn't let people see your faces properly? Facial recognition is a negotiation tool. This is Ben Weber. He has a product called Sociometric, this little thing hanging around his waist. If I were to yell right now, in about 15 minutes, all of you would feel your saliva raise the level of cortisol. It's a stress hormone, and I could sample your saliva, and I could tell that you were just stressed. He can predict with great accuracy the stress levels in your saliva in 15 minutes' time. So people wear these things into meetings, and they learn at what point people became stressed. So think about it. I have a visual technology that can tell you micro-expressions of how other people are feeling. I have an auditory technology that can tell you voice stress levels of everyone in the room. And these are actually just 2 software features that are built into your phone. Like I said, this is 10 years, not 50. How long until this stuff propagates out to everyone? Now, there's a really dark part to this, which is there are only a few companies today that can deliver this kind of technology. These 5, maybe a few others. Because they have the resources, they have the deployment in terms of platform, scale, machine learning, data access, devices, connectivity, and so on. And so if these companies decide to introduce this technology, that's a pretty sticky product. Because if I have an agent that's learned from my entire life and has become the perfect butler for me, the more I use it, the higher the switching costs. I will never cancel my spare brain. If you wonder why these companies are spending billions of dollars on big data and machine learning and interruptive interfaces, it's because they're building you a spare brain you will never be able to turn off. Once this is your spare brain, how much can I charge you a month for it? This is a very sticky product. Some may argue that this should not be a product at all. It should be a constitutional right. Now, we're not there yet. As someone famous once said, we don't have an Internet of Things. We have a lot of things on the Internet, but we're going to be there pretty soon. And everybody's got their homo metaphor, so I'm going to say I think we're quickly becoming this thing called homo connectus. And I'd made this slide like months ago, so yay, I figured out the theme at the conference. But I really do think we're building this new species. Maybe it's an interspecies between homo sapient and whatever comes next. But we are building this machine that's permanently connected. So what should we do about this? What should we do about the fact that we're going to become a species that's reliant on connectivity to external devices? First of all, some legal changes. You may have heard in the US the case of Apple being asked to unlock someone's phone. Although this is currently in debate, one of the interesting things is a police officer can compel you to use your fingerprint to unlock your phone, but not your code. Because your code is in your head and your fingerprint's outside your body. That's a pretty strange way to think about the law. And that's currently being debated, but that gives you an idea of how wrongfully we're thinking about this. Any phone knows more about you than your lawyer, and yet it doesn't have the right to plead the fifth or say, I refuse to testify, I have attorney-client privilege. So should a phone have a right? Think about it another way. There's something called the right of discovery that goes back to the Magna Carta. It's enshrined in European regulations, and it says you have the right to see the evidence against you. I think it needs to be changed to see the evidence against you using the tools of your accuser. Because if you're accused of a crime and you say, show me the evidence, and someone dumps a bunch of hard drives off, what do? If the police have facial recognition and geopositioning and satellite, and license plate tagging, you should have the right to see the evidence against you using the tools of your accuser. That's a big distinction. We need to update the Magna Carta. Here's another interesting thought experiment. Imagine some horrible murder happens here in France. And they run a query, and everybody's location can be demonstrated using their phone, with the exception of 10 people. Is that grounds enough to bring those people all in for interrogation? Because that number is greater certainty than it takes to convict someone of murder and sentence them to life in prison. At what point does the lack of a digital alibi become the grounds for suspicion? And if it shouldn't, maybe we should make some laws about that. I believe, at a very fundamental level, that nobody should know more about your life than you do. In today's world of ad tech, we have massive companies doing deep surveillance trying to reverse engineer who you are from your behavior and then not telling you about it. If I'm using Netflix and then my daughter watches a bunch of cartoons and then I turn on Netflix and all of a sudden it thinks I like Japanese cartoons, can I go and edit that? Because there's a persona, a version of me being built online that I don't own, but I should. So it's not so much about privacy. I think lack of privacy is inevitable. It's about the rights of that virtual citizen, the rights of the creature created by your data, your smart agent, and your interruptions. We need to worry about things like algorithmic regulation and real-time transparency. It's not so much that an auditor is going to look through receipts, it's that an algorithm will look through receipts, and someone needs to check to make sure the algorithm works. We saw this in the case of German cars. There were algorithms used to evaluate fuel efficiency, and they were cheating. In Nevada, Las Vegas, the Gaming Control Board has the right to inspect the source code of every gambling machine at any time. It is an algorithmic regulator. When we move more and more to algorithms deciding who gets welfare or who is a suspicious person that the police should pull over, we need people who are doing algorithmic inspection and algorithmic governance. Knowing, I think, what others know about you should be in the Constitution. I would love it if we see a world where knowing what others know about you is a fundamental human right. Because we are about to become this other species that relies on external systems. And this is going to happen faster than you think it will. Because I lied about there being three things. There's actually a fourth. Big data, not enterprise big data, but consumer big data about our lives is going to be fed to algorithms that eventually become AI, that tell us what we should do next, that notify us, that identify things, that filter for us, that think on our behalf. And when they know what to do, they will interrupt us. But they will also see whether those interruptions were successful. And that feedback will tell them what data to collect and when to interrupt better next time. And any system that is self-improving like that gets fast much more quickly than we think. The Tesla was almost driving off the road by week 1. By week 3, those things were perfect. We do not understand the speed at which feedback loops of this kind improve and accelerate what we're doing. I think we're missing the big picture. I've talked to you about a bunch of technologies. That's nice. What I'm trying to emphasize is that that trifecta of big data, smart agents, and interruptive interfaces is doing more than just giving us nice tools. It's paving the way down a slippery slope to something that will make us a human-machine hybrid. We've talked a lot about what humans will be like in 50 years. We haven't talked about how we get there. And I think this is the baby steps of how we actually go from where we are today to a world where we're really human-machine hybrids. Certainly, Juan talked about some of the biological stuff. We're seeing prosthetics and robotics that give us some of the physical components. And then this leads us down the path towards the hive mind of optimized lives and perfect recall. People who don't have this technology are going to be left behind. Those that do will seem like they have superpowers. And I don't think we are spending enough time concentrating on the ethics and the privacy issues and the legal issues and the civil rights issues and the societal issues that this presents. Because I think within 10 years, within 20 years, whenever Ray Kurzweil thinks the singularity will be here, we won't even notice the singularity. Because when the machines become intelligent, we'll be them and they'll be us. Thank you very much.